So let's take what we know about forces so far and look at our first diagram. The man is trying to move a car, but the car is not moving. The engine is not going. The question is there a force on the car? Well, yes, there would be, okay? We could say on the car, there's a force acting downwards. That's the force due to gravity. The ground is pushing up, so that's the normal force. We have the person pushing the car, so that's the applied force. And seeing that the car is not moving, he has to fight against friction. So there's our frictional force. So yeah, there's a lot of forces. Part B, no brakes, no pedaling, slowing down. Is there a force on the bike? Well, again, we always have that force due to gravity. We have a normal force. We're going to have a force of friction acting this way. And it's that force of friction that is slowing us down. We may have a velocity this way, but we're slowing down, so we have an acceleration this way. So note here that in the x direction, if we look at the sum of the force or the net force in the x direction, it is simply equal to the force of friction. We don't have to worry about the normal force or the force of gravity at this point. And that is the same direction as our acceleration. Is there a force on the golf ball? Well, again, yes. You can't shut off gravity, so there's Fg. Now, there is no normal force because the golf ball is not resting on anything. I think from the diagram we're talking about after the golf ball has been shot and is at this point in the air. So we're looking at that point and the forces acting upon it. A common mistake here is to say, well, there's the club acting on the ball, but the club acted on the ball down here, and then it stopped acting on it. So up here, the only force acting on the ball is simply the force due to gravity. We'll ignore air resistance for now. If you want to consider air resistance, you could probably say you would have air resistance somewhere like that, but I don't think we need to consider that at all. A person throws a tennis ball straight up into the air, just a small way. The questions are about the total force on the ball. If the ball is on its way up, then the force on the ball will be shown by which arrow? Well, we're assuming the ball has left the person's hand. All right, so the hand is no longer in contact with the ball. So the ball is just in the air by itself. And what we know, even just looking at our projectile motion, is that gravity always acts downwards. So that arrow could be the force of gravity there. Certainly not upwards. Okay, it's not touching the hand, so nothing's pushing it upwards. And if it is moving up, okay, there's still that force of gravity acting down. So this is the correct answer for sure. If the ball is just at the top of its flight, so again, go back to our projectile lessons, and we know that the force of gravity is always acting on it. It's not in contact with the hand. That force of gravity, again, is the only force acting on the ball, ignoring any sort of air resistance. And then if we're talking about on its way down, well, again, the only force acting on it is the force due to gravity. So again, it's answer A.